Hello, in this video we will continue discussing polynomials and in particular how we can get a vision of what the polynomial graph would look like just from the equation. After this lesson and this practice, you should be able to determine the x-intercepts, which are also known as the zeros or the roots or the solution to the polynomial equation. And to identify their multiplicities, which we'll define given a graph or the equation, and then we'll determine the equation given a graph or some description. And we should be able to sketch a decent, graph of a polynomial function given the equation. Okay, so let's start by considering the behavior of a polynomial function. In this function, we have g of x is equal to 0.2 times x minus 2 times x plus 1 times x minus 5. Now, when the polynomial equation is given in factored form like this, if it is possible to, it gives you a lot of information because you can see right away we can find the zeros. What will make this 0? Well, we know what will make it 0 is when x minus 2 is 0, right? Or when x plus 1 is 0, or when x minus 5 is 0. And if you solve these three equations, right, you can see you add 2 here to both sides, you subtract 1, you add 5, and what do you get? You'll get x is either 2, or x is negative 1, or x, whoops, this should be a 0 here. X is 5, right? So the roots, or the zeros, these are called the roots or zeros, or x-intercepts, right? Or the solutions to the equation if you were to set it equal to 0, right? So you might hear these terms used, variously to describe these numbers. Okay. Now, how do we find the y-intercept of g of x? Well, where does the y-intercept occur? It occurs when x is 0, right? So what we do is we just set x equal to 0 in this equation. So we'll say g of 0 is equal to 0.2 times 0 minus 2 times 0 plus 1 times 0 minus 5. And you can see that's just going to be 0.2 times negative 2 times 1 times negative 5, right? Multiplying these two out, you can see you get a 10 times 1. So this is really 0.2 times 10, right? Which is 2. Okay, so the y-intercept occurs at this point 0, 2, right? So the y-intercept would be 2. Okay. We can do another example. In this case, where it's given to us in not factored form, so we might have to factor this first. So you notice that this polynomial, each term has a factor of x squared, so I can take out an x squared term, and I'm also going to take out a negative 1 too. So I'll take out a negative x squared, and I'll be left with a positive 2x squared, a positive x, and a minus 3, right? And now what I'm going to do is factor this, right? So this can be factored. Now you could also use a quadratic formula here, but if you remember, we can factor this. There's a method called splitting the middle that you might remember from an algebra class, where we can say, okay, this is really 2x squared. What did I do? Plus 3 minus x minus 2x minus 3, right? And you can see now you can kind of regroup this a little bit. And you could say this is really, let me rewrite it slightly differently. I'll say this is really x times 2x plus 3, right? Minus a 1 times 2x plus 3. Right? And you'll notice the same binomial factor was revealed here. So this is really, when we factor this completely, it looks like this. Negative x squared times x minus 1 times 2x plus 3, right? So you can see there, now we can see where this, this polynomial would be 0, because we know, well, when x is 0, obviously this is 0, right? That you can see that without even factoring it. But here also when x is 1, right? Because if we plug in 1 here, 1 minus 1 is 0. So x equals 1 is also a 0. And we also can solve this little equation too, when 2x plus 3 equals 0. What is the value of x? Well, you would subtract 3, get 2x equals negative 3. Therefore, x is negative 3/2. So the other root here, or the other 0, or x-intercept, however you want to call it, is negative 3/2. Okay? Now the y-intercept here is easy to get because we're just substituting x, and notice every term, it has a factor of x in it, which is 0 for the y-intercept. So f of 0 is just 0. So 0, 0 is the point at which the, that contains a y-intercept. The y-intercept is 0. Okay. Hope this helps.